All right. So hello and welcome everyone. We are live right now. I hope I'm audible to all of you. Right. So welcome back. So I welcome all of you to this amazing platform Tutee Learning. And today we're going to revise the entire chapter of binomial theorem. Right. So as of the things are concerned, we have started with our divisions on algebra. We started with our division on quadratic equation, followed by revision on sequence and series. Right. So in today's lecture, we're going to revise the entire topic of binomial theorem, and along with that, we're also going to see how we can solve some important questions that is related to the binomial theorem, right? So the most important thing whenever we discuss a binomial theorem that comes into our mind is the how do we express the general term, right? So what I'm going to discuss over here is basically let us start to discuss and take up with the basic concepts to begin with, and then we'll also try to understand some of the important properties that will help us to get on with the things. Okay, is this clear to all of you? Okay, so whenever we talk about binomial theorem, let us first of all understand what is a binomial expansion. So generally, if we have a binomial terms, which is basically two independent terms, and if I raise it to some integer power, which is a positive integer n, so I'm writing over here, n is a basically natural number. Okay, so whenever this particular figure exists, then this expansion can be given as summation of r going from 0 to n for ncr x to the power n minus r and y to the power r, right? So this is how we write the binomial expansion of any um, two terms over here. But please note that this particular expansion can be done only when we have n as a natural number, right? Because this expression would be calculated. So ncr is basically equals to n factorial upon n minus r factorial upon r factorial, where I should have this following condition, that is n should be greater than 0 and r should be greater than or equal to 0, and also n should be greater than r, right? So this all greater than or equal to r, right? So these all conditions should be satisfied if we have to discuss with the binomial expansion, right? Now apart from this particular thing, we also need to take care of, need to understand. So this is basically what we also call as a general term. Okay, so this is something which we also called as general term. All right. Now, along with this, so whenever we write the general expansion for binomial theorem, you have to write out this particular expansion, and we try to write this expansion as T of R, right? Or like this, and where your R is going from 0 to n. So you definitely have n plus 1 terms in total, right? So there are, in general, there are n plus 1 terms. Okay, so there are in total n plus 1 terms, right? Now from here, there are certain more important things to also take care, is that how do we find out, the question regarding the middle term? So from here, we can also find out the middle term. So from here, if we need to talk about the middle term, the middle term of this particular expansion can be found out as depending upon the value of this n, because we know that if my n plus 1 is basically, so if, so in this case my middle terms are either n plus 1 by 2th term, or I will have n plus 3 by 2th term. Okay, so these are the two middle terms I will have. And in the case when, I will have n as even, then n plus 1 is definitely going to be odd, and that will gives us the middle term, that will give us the middle term as only the n by 2th term. Okay, as the n by 2th term. Okay, all right, I hope this is clear to all of you, right? And please don't be confused that whenever we write down a general term over here, it is always essential to note that, so for example over here, if we have the middle term as n by 2, I hope you can decide what is the value of r to be taken over here, right? So r value is n by 2, right? So that is how you take up and write for the general term. Okay, I hope this is clear to all of you. Okay, so what I'm trying to explain over here is that in general term, that is t of r plus 1 at term, we write it as ncr x to the power n minus r and y to the power r, right? So this is how we write the general term, right? Okay, So over here, when we have the n plus 2th term, that means r is n by 2 minus of 1. Okay. Okay. So in this case, when your n is even, so you will have only one middle term, and that middle term is basically will the n plus 2. So this is the value of r. Actually, you have to write it as this is the value of r. So you have to write the value of the term as n plus 1, n by 2 plus 1th term. Okay. So I hope this is clear to all of you, right? Now there are certain questions where you have to find out for the terms which is independent of x, right? Or the try to find the coefficient of x to the power something, right? So in order to deal with that kind of question, what we have to find it out is that when we have to find out for the terms which is independent of x, so whatever variable is present over there, you have to make that power or the indices of that particular variable as 0, right? And from there, if we have to find out for the coefficient, we have to find out the part which is multiplied with the variable, that is this particular thing, right? So this is how we find out the coefficient, right? And NCR is generally called as a binomial coefficient. All right. Now, along with this, we also need to understand some of the properties regarding binomial theorem. That is, so NCR. So we have in binomial property is that it is very symmetric. So NCR will be equals to NC n minus R. So this is one of the very important property which is regarding the binomial theorem or coefficient. Okay. And there is one more important property that is regarding the binomial, and we will be using it many times in the exam, that is also called as Pascal's identity. So NCR plus NCR plus 1 is equals to n plus 1 CR plus 1. Okay, this is a very important identity that we'll be using in solving questions. Okay, also known as the Pascal's identity. Okay, along with this, one more important thing is that whenever we need to find out the summation of all the coefficient like nc0 plus nc1 and so on up to ncn, this value is directly equals to 2 to the power n. So which is basically found out by putting my, so in the expansion of x plus y whole to the power n, if I put both x and y as 1, so I will obtain this particular relation. Okay, so this is to be taken care of in mind, right? Now, when we were discussing about the binomial expansion of for which I have the value of this n as a natural number, right? Now, what happens if we have a negative number or a fractional index, right? So, binomial for a fractional index. Okay. So, let me write it down. What will happen for the fractional or natural index? So, whenever I do this kind of binomial expansion for negative or if I have a fractional index. Okay, so if I have a negative or a fractional index, so in case when I have a negative or a fractional index, in this kind of cases, the binomial expansion, so where I also need to have that mod of r should be less than or 1, right? So I should have the absolute value of this x also to be less than 1, right? And then I can write the expansion as 1 plus nx plus n into n minus 1 n into n minus 1 by 2 factorial, okay, into x square into n into n minus 1 into n minus 2 whole divided by 3 factorial into x cube and so on up to infinity. Okay, so we'll have infinite terms in this case. Okay, where you can again express the general term as n into n minus 1 into n minus 2 and so on up to n minus r plus 1, right, and whole divided by r factorial, right? So this is to be taken care in mind, and this is to be used when n is not a positive integer. So this particular concept works for the negative or the fractional index, but please take a note in this mind that whenever I use this particular thing, I have to ensure first of all that my absolute value of x is less than 1, right? So this is to be very important and to be taken care in mind, right? I hope this discussion is clear to all of you. Right. So there are certain more important concepts that we also need to discuss along with the questions. Okay. However, the solution of questions where you have to find out the summation of the sum of the binomial coefficients of different types. In doing or solving those questions, we have to take up an understanding on how do we approach that particular thing, right? Okay. So those are also very important concepts. Now, along with this, one more important concept is very important. That is how to find out the greatest term. Okay, the greatest and numerically greatest term. Okay. So those concepts are also very, very important, or the numerically greatest term. Okay. However, whenever we need to find out the numerically greatest term in an expansion for a given value of x, use the approximation of the comparison between the consecutive terms actually helps, right? However, there are certain formulas that you can remember. Okay. However, if you watch my full length video lectures, then you must have discussed, then you must have seen that I have discussed on that particular topic itself, right? So you can watch those particular lectures as well. But for the time being, let us quickly take on this particular revision as a base revision, and then let's go to the solving some questions. Okay, through question we also try to see some of the important facts, right? So as you can see on the screen, we have with our first question. So this question we have to find out how many integral terms will exist in this kind of expansion, right? So this kind of questions are very, very important problems, especially for JEE mains. So if you are appearing for JEE mains, and these kinds of problems are very, very important, especially. Okay, and you can see in almost every attempt or every sessions of JEE mains, you will see this kinds of problem to be appearing up, right? So that makes this question very, very important. Okay, the easiest way to solve this kinds of problem is basically, what you have to do is that you have to first of all write down the general term of this kind of binomial expansion, right? So if I do over here, so if I try to write down the general term from this expansion for like this would become 1016 CR and 5 to the power 1016 minus R. So 1016 minus of R by 2 into multiplied with 7 to the power R by 8, right? So we have to find out those terms which will be the integer terms, right? So how do I find out the integer terms? The integer terms can be easily found out when this both 7 and the 5, this particular term has the integral power. So whenever this particular term has integral power, this particular combined terms would definitely yield me the integer terms, right? So from here, what I have to do is that I have to take up this particular thing 1016 minus R to be such a number which is basically a multiple of 2, and my R should also be a multiple of 8, right? So combining this two, that means I have to choose R in such a manner that satisfies both the things, right? So if I choose on the basis of this such that, and also to be noted that R is less than or equal to n, so here our n is basically 1016, right? So our n value is basically less than or equal to 1016, right? So in this case, what we'll obtain, so R should be equal to 0, R can be 8, R can be 16, and so on as 1016. So what you will notice that 1016 is also a multiple of 8, right? 1016 is also multiple of 8. So this many terms will exist, right? So let us now count over here how many terms are there. So this is basically like an AP, right? So this is basically an AP. To count the number of terms in an AP, so what I will use that, which term is basically 101 term. The first term is 0, and if I say the nth term is 1016 and the common difference is 8. So from here, I'll get the terms that is basically 128. So 128 term is 1016. That means there are total 128 terms. Okay. So there are total 128 terms. That means there are total 128 terms which are integer terms. So with this, we'll have the answer to this question as option number B. Is this clear to all of you? Are you all able to get this answer? Is this part clear? Okay, do let me know the live chat, is this part clear or not? Okay, now with this I will now move to the one of the lengthiest problems which people have said over the YouTube. I have seen many people have been discussing this question over the YouTube and said that JEE means undefined terms or the lengthiest reminder question, right? So how do we solve this kinds of problem, right? So in this class, we're going to discuss about how we can solve the remainder problems especially, okay, and also we're going to see that how this question can be solved in just a simple manner, right? So we don't have to think of a very difficult solution over here. However, we can easily approach this problem in a simple solution manner as well, right? So what is the basic solution of this kind of problems? Whenever see we have a exponential terms, which is basically something like this. So let us try to simplify this expression. So let us try to take the 64 to the power 64 as the only expression, right? So when I have this kind of expression, and if it has to be divided by 7, we have to find out the remainder, right? So the closest term which is divided by 7 for 64 is 63. So I can write this particular term as 63 plus 1 whole to the power 64, right? This is how we can write this term. So when we do this binomial expansion, the first n terms or first 64th term will be all multiples of 63, and except the last term, which is going to be only 1, right? So now this particular term, so what we observe is that the 63, this particular terms are all divisible by 7. Okay, so this particular terms are all divisible by 7. So we will have the remainder as 1 over here, right? Okay, now when we take the power, when we take the terms as 64 to the power 64 and whole to the power 64, so that basically means that this particular quantity can be expressed as 63 lambda plus 1 and whole to the power 64 again, right? This is how we express. And when we express this particular power over here, again, when we do this expansion, again, the first 63th term for this expansion also is going to be a multiple of 63. So that is something as lambda 2. Let us say lambda 2, 63 times lambda 2. And the last time is again going to be 1. Right. So when we again divide this particular power number by 7, again we're going to have the remainder as. So from this, we're going to have the remainder to be again coming as 1. Okay. So this is going to be the remainder again. Okay, so this is the most simplest way we can also approach this problem. So however, without even lifting your pen, you can easily mark this answer to this question. Okay, is this part clear to all of you? Is this part clear? All right, so if this question is clear, let's now move to discussion about the third problem. Okay, now this problem involves the summation of the binomial coefficients. Okay, so this is a problem where I was discussing about in the revision time, that you will be also seeing questions where you have to take up the summation of the binomial, right? And however, you have to do some separate modification to all of this question, right? So this is one of the very simple example of how you have to find out the binomial sum, right? So let's try to see this question. Okay, so the very first thing that comes into our mind when we look at this kind of problem is to try to notice or simplify this particular problem in terms of a shorter notation using the summation operator. So if I write it in summation operator, it is r squared times NCR, where your n is basically 15, right? So let me go from r equal to 0 to 15, right? Now here the r is not equal to 0, so it should be 1, right? So if you observe the starting term, even if you write r equal to 0, it doesn't matter, right? So it doesn't matter. Anyway, so this is how that summation is given to us, right? Now having this summation over here, we'll try to apply one of the very important property, that is NCR can be also written as n by r times n minus 1 cr minus 1. So this is one of the very important property that we use over here. So if I do that, I can write this summation as, that is r going to 1 from 15, this r square, and this 15 by this will be equal to 15 by r, and we'll have 14 c r minus 1, 14 c r minus 1. So from here, one of the r will get cancelled out, and we'll have this expression to be 15 times summation of r going from 1 to 15 will have r times 14 c r minus 1, 14 c r minus 1, right? All right. Now, to simplify this problem further, what I'm also doing is that let me try to express and write the summation as, so if you remember the summation of NCR into R, if you remember it, it is wonderful. That is basically n into 2 to the power n minus 1. But if you don't remember, so this is summation of R into NCR is n into 2 to the power n minus 1. But if you don't remember, we can also modify with this problem as, so 15 is outside the summation operator, so we have the summation from r 1 to 15. So what I'm doing is that I'm writing this r as r minus 1 plus 1, and I'm trying to represent of this kind of form, right? And then minus, so since I've added plus 1, so this can be written as plus 15 times of 14c r minus 1, right, where your r goes from 1 to 15. Okay, so we'll have this kind of notation, and then if I apply the formula over here, so this particular formula if I apply here, we're going to get the result as 15 times of 14 into, so this is basically r minus 1, so this will make it 14, so r going from 0 to 14, right? So 14 times of 2 to the power 13 plus, and this particular summation is going to be again 15 times of 2 to the power 14, because here again r is going from 0, r is from 1 to 15, so this will make r is going from 0 to 14, right? So we'll have this 2 to the power 14, and if I combine the summation, we're going to have it as 5 into 3, so I can take 15 common, and 15 can be written as 5 into 3, and then 14 can be written as 2 into 7, right? So this will basically become, so this particular part and this combined part, we will have as 2 to the power 17, okay. Sorry, it will be 2 to the power 14, 2 to the power, sorry, 13 will be taken common, okay. So 2 to the power 13 will be taken common over here, and then we'll have as 7 plus 1. So 7 plus 1 is basically going to be 8, and this will make the term as 5 into 3 into 2 to the power so 16, right? So we'll have like this, okay. If I have made a mistake, please point it out. So this is basically become 2 into 7, so that's 1 2, right? So I have to take it to the power 14. Okay, so 2 to the power 14 is taken common, and 5 into 3, and then 7 plus 1, which is again becoming 8, and this will be make it 2 to the power 17. This will in total make it 2 to the power 17, right? So therefore this expression is given as 2 to the power m, 3 to the power n, and 5 to the power n. So these values I have obtained from here, that is m is basically 17, n is basically 1, and k is basically 1. So therefore summation of m plus n is going to be equal to 19. Okay, so m plus n is equals to 19. So with this, we'll have the correct answer to this particular problem is again going to be option number B. Okay, is this part clear to all of you? Is this question clear? Okay, do let me know in the live chat, is this question clear or not, so that I can discuss it again. Okay, I hope you are able to understand this particular step over here. How did I modify this problem? Because if I have this problem in this form, the r into 14c r minus 1, then we won't be able to solve the problem, because we know the formula for this expression, right? Okay, so having known this particular formula for this expression, we can now evaluate this result very easily. Is this clear to all of you? Okay, simple and straightforward, right? Night worker, yes, correct, very good. Are you able to get it? Great. So let's now move to the fourth problem. Okay, now this problem is also very interesting problem. Again, it has combined the question of binomial expansion with the question of straight line. So you have to find out the distance of a point from this line after you found out the value for n, right? So it is just simple manipulation in the question that you have to do for. Okay, try it out. Everyone, try to solve this problem. Try to solve this problem. Okay, so if I read through the problem, it is said that if n is an integer greater than 2 and the arithmetic mean of all the coefficient of the binomial expansion of this particular term is 16. So if I write down the arithmetic mean, so that means the summation of the binomial coefficient goes from nc0 to that particular term. So since our n over here is 2n minus 3, so what is given in the problem is that CR divided by total binomial coefficient would be 2n minus 2, right? 2n minus 2, because we know that the total binomial coefficient is always the number of terms plus 1, right? And this is given as 16. This is given as 16, right? Is this clear? This is given as 16. Now from here we have to try to find out the relation of n, right? So this particular summation 2 to the power will be equals to 2 to the power 2n minus 3, and that will be equal to, so if I take this on this side, so 2 to the power 4 into 2 into n minus 1, so this will become 2 to the power 5 into n minus 1, right? Okay, so this is kind of a very non-linear equation. This is an exponential equation with a linear solution. So the only possible way to solve this problem at this moment is basically by hit and trial method, right? So we'll try to solve this problem by hit and trial method. We'll first try to put some values of n, right? So let us say we take the value of n as 2 and we try to see the solution. Okay, so if we do at 2 3 4, because n is already given as integer, so let us say I take a value of n is 2 3 4 and 5. So what you will see that if n is equal to 5, if n is equal to 5, this particular equation will hold true, right? So for n is equal to 5, I will have this 2 to the power 7 will be also equal to 2 to the power 7, right? Okay, so this will hold true only for n equal to 5, right? So for the value of n equal to 5, we'll have this expression holding true, right? That means make us a point P as point as 9, 5, and we have to find the distance of this point from this line, and the distance will turn out to be, so if I evaluate this expression, so this is 9 plus 5 minus of 8 divided by root 2, right? So I'm just using the formula in the straight lines how to find out the point and a straight line distance or perpendicular distance. So this distance would turn out to be 6 by root 2, which is nothing but 3 root 2. Okay, 3 root 2. So with this, we'll have the option D as our correct option. Is it clear to all of you? Is this question clear? Do let me know in the live chat, is this clear or not? Okay, simple, straightforward, right? All right, so let's move to the fifth problem. So we have, again, this kind of problem is very, very important. So I want all of you to solve this problem, because here we will see a very important and interesting transformation, that is the terms from the beginning and the terms from the end, right? So these are the two important things that we also need to understand. So whenever we need to count the terms from beginning, we start it as, so whenever we need to count the term, for example, 15th term from the starting or the start, then that is basically equal to T of 14, right? So T of 14 is the 15th term from the start. Okay, so whenever we write the 15th term from the start, that is basically T of 14, right? And in the case when we need to find out 15th term from the end, what we have to do is that we just need to, so this is the 15th term from the start for the expansion, let us say, of the expansion x plus y to the power n. Now when we have to find out the 15th term from the end, we have to just reverse this binomial expansion as y plus x to the power n. So 15th term from the end would be equivalent to 15th term of this particular binomial expansion. For this I am writing the terms as t dash of 14. Okay, so which is equivalent to finding out the 15th term of the opposite binomial expansion. Okay, just replace x with y. So you just replace x with y and you will get that particular thing, right? So if I do this in this manner, what I will observe over here, so the 15th term, the ratio of the 15th term from the start and the beginning and the 15th term from the end, this ratio would turn out to be, so 15th term from the starting divided by 15th term from the end, which I am representing as t dash of 15, and that is given as 1 upon 6, right? So if I do that expansion, so if I apply it over here as NC14, and we'll have a to the power n minus 14 and b to the power 14, right? So we'll have b to the power 14, and divided by, in this case also we'll have NC14 a to the power 14, and then we'll have b to the power n minus 14, and that is given as 1 upon 6. So if you simplify this expression, we'll have a will come out as, so we'll have the expression to be something as a by b whole to the power n minus 28, which is coming as 1 by 6, right? Now if I evaluate from here this a by b term, so a by b will turn out to be, so a by b will turn out to be 6 to the power 1 by 3, right? So if you simplify the expression, this is my a expression and this is my b. So if a by b is going to be 6 to the power 1 upon 3, right? So if I simplify from this expression, so 6 to the power n minus 28 whole divided by 3 is equals to 6 to the power minus 1. So from here we'll get the value of n. So if you simplify, the value of n would turn out to be 25. Okay, so from here if you simplify this expression, the value of n turn out to be 25. So you have to find out the value of 25C3. So 25C3 can be evaluated as 25 into 24 into 23 whole divided by 3 factorial, that is 6, right? So this will, so if you use just simple calculation over here, that is going to be 2300. Okay, so with this we'll have the answer to this question as option number B, which is going to be the correct answer. I hope this is clear to all of you, right? Again, a very important question, because we have learned the very important thing over here is that how to find out the terms from the end and the beginning, right? So what is the difference when we are finding out the 15th term from the end, right? So just a simple modification is that you replace x with y or a with b, right? That's how you basically get the 15th term from the end, right? Is this part clear to all of you? Okay, so with this I would like to leave some of the problems as homework problem for all of you. Okay, so this is one of the home problem that you can try to solve. Okay, so please try to solve this problem as a homework problem, and along with this please also try to solve this problem as a homework problem, right? So learning about the methods we have applied to solve questions on binomial summation you can also try to solve this problem, and do let me know whatever answer you are getting in the comments. Okay, so do let me know whatever answer you are getting. Okay, and I will be very happy to basically receive your method of solution. That will be also very interesting, okay, to learn the different ways you are solving a given problem, right? So having this being said in mind, so with this I would like to conclude the session over here, and with this we will start with our next topic, that is going to be complex number. So complex numbers, those who were saying about complex number, we're going to start complex number tomorrow. So stay tuned for complex numbers revision session tomorrow. And also, if you're into this particular platform, please hit the subscribe button and also hit the bell icon, so that whenever we are live, you get a direct notification. Okay, so with this I would like to conclude. Thank you and bye bye.